Hello, today we're going to talk about this inequality here. 2 is less than e, is less than 3, is less than pi, is less than 4. I think this is so cool. Two of the most legendary and important numbers in mathematics, namely e and pi. They are sandwiched between 2 and 4. And we're now going to prove this in two videos. In this video I'll prove that 2 is less than e is less than 3, and in another video I'll prove that 3 is less than pi is less than 4. I just want to keep the videos as short as possible, not too long, so that's why I'm splitting it over two videos. Well, we know that e is 2.718281828. You can go on a calculator and see that, so it's pretty obvious from the numerical result on a calculator that 2 is less than e is less than 3. But now we prove why this is true. We show why e must be bigger than 2 and it must be less than 3. So we'll prove that rigorously, not just because we went on a calculator and it gave us the answer. Where did it come from? So we'll more or less do this in one go. So let's dig in. E can be defined in various ways, and it has some very special properties. Consider the function f of x equals e to the x. And that has Taylor series. E to the x is the sum from n equals 0 to infinity, x to the n over n factorial. We're not going to prove that in this video. I'll maybe discuss Taylor series in another video. But that is a well-known result. So the Taylor series for e is simply e, so we're letting x equal 1, so e to the 1 is e. So the number e, which is approximately 2.718, is equal to the sum from n equals 0 to infinity of 1 over n factorial, because x to the n becomes 1, because x is 1 no matter what n we choose. So it collapses to that. So e is equal to 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus all the way to infinity. You're just increasing the factorial in the denominator by 1 each step. So e is equal to 1 over 1 plus 1 over 1 plus 1 over 2 plus 1 over 6 plus da da da. So the 1, 2 and 3 factorials are pretty obvious. 1 factorial is just 1. You're not multiplying it by anything. 2 factorial is 1 times 2, which is 2. 3 factorial is 1 times 2 times 3, which is 6. Now 0 factorial is also 1, and I'm not going to prove that in this video, but the result is fairly straightforward, and as I say, I may make another video on that, but 0 factorial is 1 as well. Okay, so then that means that e is 1 plus 1, because 1 over 1 is just 1, plus a half, plus a sixth, plus 1 over 24, plus 1 over 20, etc. So e is equal to 1 plus 1. So I've highlighted in yellow the two integers in this infinite series. So the first two are just 1. So 1 plus 1 plus all the stuff in blue. These are all fractions. These are all less than 1, greater than 0. All those numbers lie between 0 and 1. So put them in blue. So that means e is equal to 2 plus all of that stuff. So I've just gathered the two ones together and called it e equals 2 plus all of that stuff. So therefore, obviously e is equal to 2, and the result follows. Now we will prove that e is less than 3. So we already proved e is equal to 2 plus all of that stuff. So all we need to do now is prove that the blue stuff is less than 1. And then that means e is less than 3. So that means we have to prove that the sum from n equals 2 to infinity of 1 over n factorial is less than 1. All we've done there is taken the Taylor series and we've taken off the first two terms where n is 0 and n is 1, because we've already counted them and they are equal to 2. Well, a half plus a sixth plus a 24th plus a 20th plus a 7/20th plus da 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 is less than a half plus a sixth plus an 18th plus a 54th plus a 1 over 62 plus plus plus. Now, where did that come from? Well, I've done a little trick there. All I've done is, it's kind of like a comparison. So the first series at the top, this is what we're trying to prove is less than 1. So I've rewritten that down. And the series below it, as some of you may have already worked out, is a geometric series with first term 1/2 and common ratio 1/3. Now I've done that on purpose, as I say, because geometric series are very special. They have special properties which allows us to sum them to infinity very easily using a well-known formula. Now I've chose that specific one because that is definitely bigger than the Taylor series inequality at the top. And why? Well, because the first two terms are equal, obviously, so it's not obvious from those terms. But if you look at the terms after that, you've got a 24th on the top, and that's less than 1 over 18. Then you've got 1 over 20 on the top, and that's less than 1 over 54. And every subsequent term will be less than the corresponding term in the sequence below. And why is that? Well, in the top series, the denominators are going up. You've got n factorial, and then you've got n plus 1 factorial, and then you've got n plus 1 factorial. So they're going up by 1. The factorial increases by 1. So if you look at the factor from the one term to the next, 2 to 6 is multiplying by 3. That's the same at the bottom. 6 to 24 is multiplying by 4. But on the bottom is still staying at 3. And every term in the bottom series, denominators, all increase by a factor of 3. But in the top series, they're not all increasing by a factor of 3. They're increasing by 3, and then 4, and then 5, and then 6, and so on. So from that, it's pretty easy to conclude that the top series is less than the bottom series. Now that bottom series, as I said, is a geometric series. First term 1/2, common ratio 1/3. And this is obviously an infinite series as defined by the Taylor series above. So we are taking the sum to infinity of a geometric series. The formula for the sum to infinity of a geometric series is given by sum to infinity is equal to a over 1 minus r, where a is the first term of the series and r equals 1/3 is the common ratio, and r must be less than 1. So that bottom series becomes a half plus a 6 plus an 18 plus a 54th all the way to infinity. A is a half, r is a third. Plug them in, you get a half over 1 minus a third is a half over 2/3. When you divide by a fraction, you multiply by the reciprocal. So that's equal to a half times 3 over 2, and that's 3/4. So that means the sum from n equals 2 to infinity of 1 over n factorial is 3/4, which is clearly less than 1. So therefore e is less than 2 plus 3/4, which is 2.75. So therefore e is less than 3. And our result is now proved. In fact, we've actually proved a stronger result. We've actually proved that e is less than 2.75. That wasn't what we required to do though. We only required to show that it was less than 3. But we got that as a bonus. So we've proved that 2 is less than e is less than 3. In another video, I'll prove that 3 is less than pi is less than 4. So I'm very excited about that video. Get ready for that, guys. I'm going to prove it in a slightly different way. This video I proved more using algebra, and in the pi video I'm going to use more geometry. So that concludes this video, so have fun with E. Thanks for watching, please subscribe, and I'll see you on the next video.